So the natural log of x. Let's look at, in black is our natural log of x. There we have our derivative. And if you were to drag that derivative all along, we get this graph. It almost looks like a reflection, doesn't it? It's not quite a reflection. Because the graph that we end up getting, as we keep going, the limits of these slopes, they're flattening out, but they never get completely flat. So they're getting closer to 0, but the natural log of x is still always increasing as you go off to infinity. So since it's always increasing, you'll always have that positive slope there. There's an asymptote. And since the value at x equals 0 does not exist for a natural log, there is also an asymptote there. So what kind of graph does this look like? Well, it's sometimes hard to see, but if I drew the same thing over here on this side, you might say, hey, I do recognize that. That's the same as my 1 over x graph. So if you have the natural log of x, the derivative of it is 1 over x, but it's only when x is bigger than 0, because natural log of x didn't exist when x was less than or equal to 0. So anytime you have a natural log, the derivative of it will be 1 over x. So for this first one, I'm just going to keep this 5 out in front, and I'm going to write the 1 over x in brackets. Because you're going to be tempted, I mean, eventually I'd love it if you could just go to this directly. Okay? But you might be tempted to move the 5 to the bottom as well. That 5 is a constant out in front that gets multiplied by the 1 over x. And if you think of that 5 as 5 over 1, when you multiply those fractions, you'll get 5 over x, not 1 over 5x. Same thing here. If we have a base other than e, we've got the natural log of b coming in the bottom. It's still 1 over x, but then you're also multiplying by the natural log of b as well. In order to prove this one, you could use your change of base theorem. So your change of base theorem says that I can take any logarithm and change it to any base that I want. Since I know that the derivative of natural log of x is 1 over x, that might be a good base to change it to. Change of base theorem looks like this. You make your new base whatever you want of x divided by whatever's on the bottom. That's our change of base theorem. This part, this letter a, you can choose as anything. So because I can choose it as anything, I could choose it as e. So that would make it natural log of x divided by natural log of b. And the natural log of b, since b is a number, is just some constant. So then when you're doing the derivative, and you're doing the derivative of this, you would have that 1 over natural log of b still out in front, multiplied by the derivative of ln x, which is 1 over x. And that matches up with what we had to begin with. Yes?